Hi everyone, welcome to the video. I'm Shakur and today we are going to solve this mechanics of material problem together. Once we draw the free body diagram, the rest won't be hard. Okay, let's read the question together. Link BD consists of a single bar 1 inch wide and a half of an inch thing. Knowing that each pin has a 3/8 of an inch diameter, determine the maximum value of the average normal stress in link BD if A theta equal 0 and B theta equal 90 degree. Again, as usual, let's go back to the free body diagram and sketch the loads and support reaction. At point B, we have the force FBD, and at support A, we have two reaction AX and AY, which we have already drawn. I should change this AY and AX. Okay, the general equation we have is sigma equal force divided by area, and for the area we have this figure, and we need this part of the area, which is equal 1 minus 3/8 multiplied by a half. It's equal 0.3125 of an inch. The area is exactly like the cross-section area we solved in one of the previous problem, and now we write the moment equation about supports A. It means sigma m about A is positive equals 0. It means if BD multiplied this, it's 12 cosine 30 degree minus, and we consider this force FC plus FC cosine theta, it's equal this. This is FC, this is FC cosine theta, and this is FC sine theta. FC cosine theta multiplied this value, which is equal 12 plus 6. No, sorry, it's this value. 12 plus 6 sine 30 degree, it's 18. 18 sine 30 degree and minus FC sine theta multiplied this value, it's equal 12 plus 6 multiplied cosine 30 degree, it's 80, that's 18 cosine 30 degree. Let's move this equation to here, and for part A we should consider for A theta equal 0. It means cosine theta equal 1 and sine theta it's equal 0. That's part B0, and here we have minus f BD multiplied 12 cosine 30 degree plus FC multiplied 18 sine 30 degree. And we know that FC is equal 4 keeps equal 0, and finally we have FBD equal approximately 3.4641 keeps, and for sigma BD we have FBD divided by ABD, it's equal 3.641 keeps divided by the area. Here we have 0.3125 inch. 0.3125 square inch. I forget the sign square here, and that's approximately equal 11.08512 kc. Let's move to part B. For part B, theta equal 90 degree. It means cosine theta equals 0, and this part equals 0 too, and sine theta be 1, and finally we have minus f BD multiplied 12 cosine 30 degree plus minus FC multiplied 18 cosine 30 degree, and know that FC is equal 4 keeps. Here equals 0, and here FBD it's equal minus 6 keeps. Here, because of this sign, the FBD is compression. It means the area is different and it's not equal this part. And the area for compression loading, it's equal area for compression, it's equal, we have a rectangular and it's 1 multiplied a half, it's equal 0.5 square inch. And according to the area and the load, here we have sigma BD equal FBD divided by the area for compression loading, and it's equal minus 6 keeps divided by 0.5 square inch, and it's equal 12 kc. That's it. I hope you find it useful.